Good afternoon. This is Mathcast number 1, creation date 9/18/24. The intended audience is grade 4. Our learning objective is identify, define, and draw parallel lines. This is created by Xander Gage. Here's some vocabulary to keep in mind. Our first vocab word is going to be parallel lines. So it's defined over here. Parallel lines are two coplanar lines that don't intersect. In a coordinate geometry, the graphs of two linear functions with the same slope. So in our picture here, right, we have these two lines right here, this red one and this other red one. See how they go straight and there's no possibility of them ever intersecting? The same thing with L1 and L2 here. Those are parallel because there is no chance of them ever intersecting. Later on, there'll be more examples to show more parallel lines, and we'll go over it when we get there. Our second vocab is going to be regular polygon. So regular polygon is a polygon with congruent sides and congruent interior angles. So we can see these little lines here all indicate that each one of these sides is congruent, and these angles are all the same angle. Other examples are this equilateral triangle, which is the same as this. The square, all the sides are the same length. All these angles are 90 degrees. The regular pentagon, all the sides are the same and all the angles, and the same can be said for the hexagon. Our last vocab word is going to be congruent or congruence. Similar, not totally identical, but similar. So this is the state of equality between two or more angle measures, side lengths, and other geometric properties. Two figures or corresponding parts of figures can be congruent. So in these triangles right here, they're congruent because these lines on the sides of the triangle all match up. So A to B is congruent with D to E, C to B is congruent with F to E, and A to C is congruent with D to F. And these angles right here are the same angle. They're identical. They have the same angle measure, and the same thing applies for these lines. These two sides have identical length. Let's take a look at our first example here. So example number 1 says, on each object, trace at least one pair of parallel lines. So let's look at the t-shirt. So we know that parallel lines mean the lines that are coplanar, they'll never intersect. So if we look at this t-shirt, what lines are we thinking? It's most likely these two lines, because on this t-shirt, they will never cross. Never. Let's move on to this sign, the two-way sign. So on this sign, if we look at it, none of the outside edges are parallel. It depends on what you look at it. Actually, yes, they are. I lied. So right here, this line and this line are parallel. This line and this line are parallel. Inside the sign, this line and this line are parallel. This line and this line are parallel. All those lines that are colored out in different colors will never intersect each other. Never. Let's move on to our guitar. So if we look at our guitar, we can look at these right here where the strings are, like the arm looking thing. That goes straight out. The lines will never intersect. Nothing else on this guitar is parallel. Let's look at our flower pot. So if we look at our flower pot, we have one set of lines that are going to be parallel, or that are parallel. It's going to be this one and this one right here. Those are parallel. They're never going to cross. So we're going to move on to our shopping cart. There's a lot of examples in our shopping cart. I'm going to use one color. It's all going to be green. So this line is going to be parallel. This line's parallel. Inside these little nits, this line's parallel, this line's parallel, this line's parallel, this line's parallel with this one and this one. All those lines are all parallel because they're never going to cross. And this line, these two lines are parallel. They're never going to cross. This line, additionally with these, are never going to cross. And our final example to show this for this section, for this question, is what's going to be parallel. All these support beams are going to be parallel. All these support beams are going to be parallel with each other. And that's all we have in here that is going to be parallel. Our second question is, how do you know if two lines are parallel? So if we think back to our vocab and the last example, they're coplanar lines that will never intersect. So you will always know that they're parallel if you see two straight lines like this and like this that are never going to cross. If you see a line like this and a line like this, yes, they don't intersect here, but if we keep going with it, if we extend this one this way and this one this way, they intersect at this point right here. So we'll know that lines are parallel if they never cross at any point in time. They can go on for 1,000 years and they'll never cross. Our final question here says, explain why line AB and CD are parallel, but EF and GH are not. And just a little side note, these lines on top of these are that says segment. So GH is a segment, EF is a segment, AB is a segment, and CD is a segment. So in AB and CD, we know they are parallel because these two coplanar lines that extend this way, that way, and that way will never come to an intersection ever. They will never cross. They're going to be coplanar. But for E, F, and GH, we're going to switch colors. If you extend this one this way, it's going to go off screen, and this one this way, they're going to come to an intersection. So that means they are not parallel because they intersect at some point somewhere off in the future. It could be 1,000,000 years, 1,000,000,000 years, whatever. It will come to an intersection point at some point in time. Thank you for watching my MathCast 1. Our MathCast resources are plugged in right there. This was created by Xander Gage. Have a wonderful night and see you next time.